Uh, Myself, Raghunath Reddy, working as assistant professor in Dayanand Sagar College of Engineering. This semester, fifth semester, MOP lab, op-amp and measurements lab, it will be there. I have written subject name, measurements and op-amp lab, and the code of the subject is 18EE5DL MOL, and this is conducted Department of EEE, fifth semester students. Especially in this lab we are going to studying, or we are going to conducting experiments, totally 10. Out of 10 experiments, we are 6 experiments we are conducting on op-amp kit, and the remaining 4 experiments we are conducting individually based on the experiment title. Okay. Now before going to the lab or before conducting the experiments, we should know what the components we are going to study, or what kit we are using to conduct the experiment. Okay. I told you, right, op-amp kit, 6 experiments we are going to conduct it, that I will show in the latter. First I will give brief introduction about what the components we are going to using. See, in the first experiment, we are conducting the improvement of power factor for fluorescent lamp. For the fluorescent lamp, with capacitor and without capacitor, how the power factor we are going to measuring, and how the power factor is improved by seeing the circuit and the calculations we are going to doing. And like similarly, like AC DC current measurement, and then single phase energy meter, and bridges. Okay, bridges to finding the inductance and to finding the capacitance values. For op-amp, different experiment we'll see later. Before going to experiment, I'll show what the components we are going to using. Already you are familiar with these components like ammeter, voltmeter, wattmeter. Earlier we have used in the laboratories, like machine laboratories. Now I'll show the individual component and what we are going to. What is this? Okay. This is a single phase energy meter. Like we have domestic energy meter in the home, we are going to using this. What we are going to here, the calibration we are performing. See, calibration in the sense, suppose whether the energy meter is giving proper reading the proper values or not. It is having any error. If it is error, the designer will take care about that to compensating of the error. But now whether whatever the existing meter, whether it is having error or not, we will calculate by actual, and what is the energy recording for this instrument. And now come back to the voltmeter. See, we already know this voltmeter, AC voltmeter, which is measured to voltage and AC voltage, and this is a ammeter. Okay, ammeter used for, you know, that to measure the current. And one more instrument, what you call one more instrument, it is a wattmeter. Okay, wattmeter we are going to using. We know that to measure the power. Okay, suppose this is and all the AC meters only, because the experiments are related with AC. Here we are conducting. And one more, this is a bridge circuit, Maxwell inductance bridge. What purpose we are going to finding the Maxwell inductance bridge? We are finding the unknown inductance. This is a unknown inductance value. From this to demonstrate, okay, to know, suppose only we are different values. Instead of this, we will use the Descartes inductance box. In that Descartes inductance box, we will get so many variations, and we can know. First we will find out the known value. Then we will give it this unknown value. They can easily find out. And next, this is a oscillator. To produce what you call oscillations. To produce the oscillations. Now this it will be used in the bridges. Okay, both the inductance, Maxwell inductance and capacitance bridge, and as well as Shearing bridge. Okay, both for that we are using this oscillator, and this is a unknown capacitance value. This unknown capacitance, it will be same. If you see the what you call shapes or size, both it will be same, but we can plot it on the box. And these are the headphones. Whether the bridge is balanced or not by the noise, we can listen. Okay, Instead of the headphones, so we can use the galvanometers also. AC galvanometers we have used because these are all the AC bridges. Okay, and this is a one more kit. See, this is to measure the capacitance. We are using the D Shortest bridge. Okay, this is a D Shortest bridge. See, in the previously I have explained about the for to conducting of measurements, what components we have used, and now for the kit like op-amp, operational amplifier, we have developed, the Department of EEE itself have been developed a kit to perform. Okay, we can perform many experiments, but based on the time and based on what experiments is needed for the UG students. Okay, we can go beyond this also. But now we have 6 experiments we are going to conducting on a single kit. We have totally the 6 kits at a time. Parallelly we can conduct 6 experiments. Now coming to the kit, this is a op-amp kit. PCB we have designed and all the components are fabricated here. Now what we are going to providing here, this is a transformer, step down transformer. From here, this is connection we are giving to the, we are inserting socket into the plug. We are getting the 230 volts, 220 volts, and that it will be stepped down to the 12 volts. We are using here center trap transformer. We can see here the 3 wires. One is red, yellow, and then orange wires, and middle one is a 0 volts, and here these 2 are 12 volts. Means it is a step down transformer. We are to supply to obtaining of supply. We are giving to this what do you call 12 0 12 0 12 0 12 volts of the supply we are going to getting. Before explaining this operation, I will tell what are the components or what are the components we have fabricated in the op-amp kit. Okay, this is a capacitor. You know this capacitor, and these are the edge connectors. We call blue color edge connectors, and this is a black color is a rectifier. Okay, bridge rectifier, and this is a voltage regulators. Okay, to restrict the voltage, to provide the supply to the op-amp. We are using the plus or minus 12 volts. One is a positive voltage regulator, another one is a negative voltage regulator. This is a voltage regulator. This is a voltage regulator. And now what is this metallic part? It is a sink, heat sink. Okay, if suppose the heat is developed by the IC and it will be absorbed, the heat sinks, it will be absorbed. And see here, right, these are indicators, 2 indicators, and which one is what do you call it, whether the positive or negative supply you are getting. This completely the portion, this portion is for to obtain of plus or minus 12 volts. Okay, what purpose the rectifier we have used? We are converting the AC voltage, the 12 volts AC voltage to, we are converting it to the 12 volts DC to obtaining of fixed supply, positive and negative supply, and then we are using the regulators. See this all the what do you call the plus minus plus 12 volts and minus 12 volts. We have supplied the complete entire kit. We have totally here portions we are divided A, B, C and D, E. Till the E parts we have categorized, and each part we are going to conducting a different experiment. Suppose for example in the part A, this is a number we have indicated here, A the number, and this is the IC which LM324 IC we are going to using. Okay, I told you already these blue colors are H connectors. H connectors means input and output we can provide it, or this already you know, these are all resistor. And what is it? This is IC base. Okay, what purpose? Actually we can fix the ICs and we can solder, but suppose if any failure of IC we cannot replace. If your solder means unsoldering is a very difficult task. That's why we have used the machine base. Okay, IC machine bases Then we can, suppose if any IC failure is there, we have a test kit. First, before operating of this IC, we will check once. And then we will allow to conduct the student to perform the experiments. Now in the A portion, B portion, and then C, and then D, and then E. These are the portions we are going to conducting the 6 experiments: inverting and non-inverting amplifier, difference amplifier, schemic trigger, and saturation precision full wave and half wave. And we are performing the oscillators also, Wien bridge oscillator and RC phase shift oscillator, and waveform generator, integrator, and differentiator. These are the experiments we are conducting on the complete this kit. Okay. Now by seeing this, we can easily observe that what the components. Suppose this is the number also we have fabricated, everything we have done. Okay, this image, okay, the clear picturized image, and the circuits also we will provide in the manual. And for your easy understanding purpose, I am explaining what the components we are used. And this one is already known. This is a PN junction diode. Okay, this is a PN junction diode. And these are the resistors, different values. You know how to calculate by using the WebGL. Okay, and the value of the resistor value, we know the formulas and all. Okay, these are the kit explanation point of view. Okay, 6 experiments we are going to conduct. And now to perform the experiments, we need some more additional components. Those are this is already have seen in the AEC lab, I think so. This is a decad resistance box. Decad resistance box can be used to get the various resistance values from 1 ohm to 100 into 10 kilo ohms. Okay, and we are using the capacitance box also. The capacitance box for AC. Okay, for if you want to conduct the AC amplification point of view, AC amplifiers, definitely we need a capacitance and R value also. The capacitor values also 100 picofarads to and 10 microfarads. We will obtain the capacitance, and we can get the many variations in the amplification point of view, AC amplifiers. And you know already this is CRO, and this function also you are already studied, okay, in the AEC lab. But for your understanding purpose, just I'll brief about this CRO. This you know that CRT tube and the display part, and this is a power switch. Okay, and these are the different modes we have, consisting of 2 channels. Okay, 2 channel 1 and channel 2, and whichever is applicable. Suppose if you want to see both input and output by connecting the probe, okay, and we will see the input as well as output. If you want to use the both channels, it should be in a both mode. Okay, both mode we have to apply. Then we know these are the operating procedure also. While conducting the experiment, I'll explain. And this already you are familiar with. This is a signal generator. From this using of signal generators, we can generate sinusoidal, triangle, and then square, and then pulse. Okay, and inverse of pulse. Everything you can obtain. And the peak magnitude. This is a variation of peak magnitude. This is a variation of frequency. Okay, this is for offset value. Suppose if any offset is provided from the input signal, we can negotiate it, whether it is a positive offset or the negative offset. Okay, these are all the components. These are the major equipments are used in the measurements lab. Other than the components like voltmeter, multimeters, regulated power supplies 0 to 30 volts, suitable connecting bias we will use it. Okay, and the next session I'll explain about each and individual experiments. Some of the experiments also will be given inputs to our faculty members, and I'll also explain some of the experiments. And totally out of 10 experiments, the complete experiment by experiment videos will be provided. This is a demo video or the introduction video for the measurements and op-amp lab. Thank you very much.